So very good afternoon to all. Am I audible?
Good afternoon, sir. You're audible.
Hello. Am I audible?
Yes, sir.
Yes, sir.
Sir, you're
Okay.
audible.
So all of you are getting the screen?
Yes, sir.
Okay.
Yes, sir.
So from this lecture onwards, we have started our syllabus, which is the first chapter, which is called the vector analysis. Okay. In terms of the vector, already you are knowing the vector have a magnitude as well as the direction, and the scalar have a only magnitude components. Okay. So the some of the example you may be considering the for the scalar field, it may be like a temperature, it may be a mass, some kind of a volume, density. So it's a basically single unit. Temperature can be measured in terms of centigrade, mass maybe in terms of the kg. Same case in terms of the vector field, you can represent the example is maybe gravitational force, velocity, acceleration, magnetic field intensity, displacement, electric field intensity. These are some of the example of the vector field, where you can measure the velocity, maybe meter per second. Same case the magnetic flux density, it may be a uh, ampere per meter. Same case electric field intensity is the volt per meter. Okay. So it may be question why it is required to deal with a vector field. The reason is whenever you are transmitting the any signals in a free space, like you are transmitting the any signals in a free space. So whenever you're transmitting it, it has some direction, and this signal has some kind of a amplitude part. Yeah. So whenever if any amplitude or any kind of your direction should be present, then it is considered some kind of a vector. Okay. Field is nothing but a this kind of a quantity which is maybe uniformly or maybe not uniformly distributed in a some surrounding region. That's why it is called the field, like a ground field, maybe electric field. So electric field means your electrical charge will be a uniformly or maybe not uniformly distributed in a sum of the region. That is called the field. Based on the vector, it may be any quantity. Based on the electric, it may be any kind of your electrical charge, and based on the magnetic, it may be a any kind of your magnetic charge. Okay. So this is a simple example of your scalar as well as the vector field, and we are more concentrated on a vector field because the any sine wave can be represented in terms of the vector field. For each and every point on your sine wave, it's have a magnitude as well as the direction. So that's why you can represent these components as a vector field. Sine wave can be also represented with some kind of a component which is nothing but a vector field. Now, if you're dealing with a vector, then it means it have a magnitude as well as the direction. Okay. So magnitude is already known to you, and direction can be represented with like in 12th standard you are mentioning with a I, J, and K. Okay. But in this case we are mentioning it's a X, Y, and Z. Okay. Instead of the I, J, K, now it is the X, Y, and Z. Okay. Before we going to this vector algebra, we just discussed the types of the vector. Okay. So different types of the vector which may be a represent with this one. Like a first example is uh, suppose I am interested to mention the any point in a free space. So can anybody tell me how to mention the any point in a free space? Any answer from your side?
So with the help of X, Y, and Z coordinate.
Yeah, with the help of x, y, and z coordinate, you can locate the any point in a free space. Free space means anything. Everywhere you can locate this particular point. Okay, so this system is nothing but already you are knowing it is a Cartesian coordinate system. Okay, like this is the x-axis, this is the y-axis, and z-axis have a different plane in terms of the x, y, and z. So there is some origin, and from the origin you can move either x, y, or z direction. Second figure is indicate, suppose I'm interested to locate the any point in a free space. So consider like a point P is equal to 1, 2, and 3. So 1 is equal to x, 2 is basically y, and 3 is basically a z. So you to just move in a x direction is equal to 1, y direction is equal to 2, and the 3 it's basically z direction. Okay, but if you just mention the 1, 2, and 3, what is exactly indicate? This is the magnitude part, because 1, 2, 3 is the magnitude. Okay, but same point, if I want to convert into a vector form, then what you have to write down? You can write down it's a magnitude as well as the direction. Okay, now see, already you are knowing the magnitude in x direction it's 1, and the direction is x. So you can mention it is the a of x. Let us discuss what is a of x. Clear? Suppose I am interested to mention this point P123 in a vector form. So what you can mention? A of x multiply with a 1 plus 2 a of y plus 3 a of z. Okay, so if I just consider the first part, it means a of x. If I multiply with 1, means it's only the 1, so that's why it is only a of x. A of x is basically a direction or maybe unit vector with respect to direction of x. 2 a of y, because the 2 is the magnitude in a y direction, and you are knowing the direction is y, so it is a of y, and plus it is 3 of a of z. Same way you can also mention this point like a 2 minus 2 and 1. Okay, so any point can be represented in terms of the magnitude part as well as the vector form. Suppose someone is asking if I want to locate the point P 0, 0 and 3. So can anybody give me the answer? What is the vector form over here for this particular point?
So what are the points?
Point is 0, 0, 3.
So the point is on z-axis with 3 units ahead from 0.
Yeah, a point in a z axis, but I'm interested to mention in a vector form. So how you can mention it?
3z, sir.
3z, 0x
Yeah.
plus 3z.
Remember, it's not a only multiplication of z. Remember, it's a of z. A of z. Z is a small one. Clear? I'm giving one example. Maybe you are getting the idea. So suppose the point is 0, 0, 3. It means the x and y component is 0, but z component have a some value which have a 3. So I can write down it is 3az. Similar, if I give another example, consider the q. It may be 1, 0, 1. So what you can write down? A of x plus a of z. Clear? A of x plus a of z, because the y component is 0. So you can mention this point in a xyz direction using the unit vector. Now see what we are doing. Suppose if I'm interested to mention the any vector in a free space. Okay, I'm taking the same point P1, 2, and 3. Okay, and they're given the some direction which may be mentioned over here. Just see the figure A. Like you are knowing how to find out the magnitude. Suppose xyz is given to you, and consider this point is maybe 1, 2, 3. In a figure A, there is a arrow mark, black color arrow mark. Consider this point is 1, 2, and 3. And if I'm interested to find out the magnitude, already you are knowing how you can find out under root of x square plus y square plus z square. This is the magnitude of this particular vector r. Okay, and this is the direction. Now see the direction, it's mentioned on your screen with a figure B. What does exactly indicate? In a x direction, it is a of x. Suppose someone is telling you x direction magnitude is phi. So what you can write down? Phi a of x. Clear? Suppose someone is telling you the y direction magnitude is 0. Then no need to multiply with a of phi because by default the magnitude part is 0. And the direction of the z it have a 1. Then you can write down it is the a of z. Okay. So for perfect representation of the vector a, it means magnitude and the direction. Magnitude is always mentioned with a capital A of x and capital A of y and capital A of z. And direction will be mentioned with a small a of x, which is mentioned on a screen, which is the a of x, a of y, and this is a of z. Okay. I given another example, just wait. Getting the figure on your screen?
Yes, sir.
Okay.
Yes,
So see,
sir.
the figure B, right hand side, they are mentioning the vector. Which vector? Vector A. Okay. So how exactly you can mention the vector A? Vector A is equal to A of x, A of y, and A of z. Okay. But A of x is have two components. Magnitude is represented with a capital A of x. So suppose it is 2, then it is a of capital A of x is a 2. 2 multiply with a small a of x. Okay. Remember it, small a of x is always the direction. And if you are multiplying with any magnitude, right now capital A of x is considered 2, then it is a magnitude of the x. Okay. Similar one, a of y, capital A of y into small a of y, and capital A of z into the small a of z. This is the representation of the vector. So how exactly you can write down the vector A? It's this one. All of you are getting it?
Yes, sir.
The equation
Yes,
1.7,
sir.
the capital A of x into A of x plus capital A of y into small a of y plus capital A of z into small a of z is equal to A. And already you are knowing vector A will be mentioned with a arrow mark. A with a arrow mark. Clear? Normally your mention is a cape, but instead of the cape, now you have to prefer it's a arrow. Okay. So this is the representation of the vector. Okay. And equation 1.7 in a bracket, they are mentioning capital A of x, capital A of y, and capital A of z. So it's see, in this case, it's only the magnitude because it is a capital A. And in this case, it is a magnitude as well as the direction. Hope so this part is clear.
Yes, sir.
Okay. So this is the representation of the vector capital A of x, small a of x plus a y and a of y plus capital A z and a of z. Now based on the vector, you can easily find out this magnitude. It is already known like under root of a of x plus a y square plus a of z. Okay. Now we are interested to mention the representation of the vector. Graphical representation of the vector. Okay, so there is a two different rule. One is the parallelogram rule and second is the head to tail rule. Suppose assume in a figure A on your screen, which is a some vector representation A and B. Why you are telling it's a vector representation? Just see the direction of the B. Can I consider direction of the B is a represent with some direction and there is a finite length? And A, it have some direction and it have some finite length. So it have a magnitude as well as the direction. Okay. So A and B, it's a basically vector. If I add these two vector, then resultant vector is the C. So it's already mentioned on your screen with the C is something over here. It's a basically addition of A plus B. Okay. This rule, it's called the parallelogram rule. Representation of the vector in a graphical form. Okay. So I can write down C is equal to A plus B. But suppose someone is telling you, mention the A minus B in a graphical form. Vector A minus B. So can anybody give me the answer? How you can represent it?
Sir, we will change the direction of B to the opposite side.
Yeah, it's perfectly fine. So see, A minus B. Direction of the B, it's a negative one because it is minus B. So right now this is B. So I can write down it in a which direction? Left hand side. Clear? It is in a left hand side. So minus B in this direction. And the resultant C, which is in this direction. You maybe find out over here. Just see the figure 1.3a, this one. Clear? This is already it's B and it is A, but you are considering it's a minus B, then it is in this direction. Minus B. And resultant vector it's mentioned with a D right now. So it's a basically representation of the A minus B for the parallelogram rule. Same one you can represent with a head to tail rule. Okay. What is the meaning of this one? Suppose assume you are knowing this vector A in a some specific direction. Okay. You are also knowing this is the vector B. Okay. If suppose the vector B, if I mention over here or if I mention over, anything is changed?
No, sir.
No, because both have a same length and same direction. Nothing is changed. Okay. So head to tail is rule is indicate if one vector is finished, second is started in the same direction. In the means whatever the direction of the B. Okay. So right now this is the vector A. Instead of this B, I'm mentioning it is over here. So it is the resultant vector have a no effect. And the resultant answer have a no effect. So this is called the head to tail rule. Same case if I mention with a negative one, like a minus B in terms of the negative one. So what you can represent? See, this is B and the direction is changed. So instead of the A, right now it is B. Clear? So this is called the graphical representation of the vector either in terms of the addition or either in terms of the subtraction. Okay. Second part is the different types of the vector. It means it have a positional vector, it have a distance vector, it have a unit vector. Okay. It's request to all the students always you to take with a piece of the paper or take some note with some pen, because this subject is not only a simple you can read once and you may be getting the marks. Okay, you have to mention the each and everything in your book, then it will be easy to understand the each and everything. So it's a request to all, always take some piece of the paper or maybe some note. Okay, so the types of the vector may be a 3. I'm directly given one example, so you may be getting idea. The first vector, which is called the positional vector. The first vector, which is called the positional vector. Second is called the unit vector, and third is called the distance vector. Okay, so just see the figure C. There is a point which is mentioned on your screen. It's a 1, 2, and 3. Okay, now if you draw a line from the origin to the point P, which have a value, it's a 1, 2, and 3. Okay, suppose some point is given to you. Consider 0, 0, 1, maybe 1, 0, 1, maybe 3 value is present, 2, 2, 1. Okay, if I mention the any distance from origin to the point P, so right now can anybody tell me which vector will be considered as a positional vector in this screen?
RP.
Yeah, it's a RP. Okay, so this is your origin. From the origin, I'm mentioning the distance vector. I'm mentioning the positional vector. It's a 1, 2, and 3. Okay, so normally this positional vector will be mentioned with a small r. and the point P, then it is a P. If it is Q, then consider as a Q. Take the second example of the position vector Q. Okay, so just see the R of Q. So positional vector can be useful to locate the any point on your free space. This is the functionality, or we can consider the application of this positional vector. Positional vector can be mentioned with a small r with any point, and always they are mentioning from the origin towards the point, and they are always considering the distance. They are always considering the distance from the origin one. Okay, and they are mentioned with the r of p as well as the r of q. Okay. Now see, now you have a two vector r of p and r of q. Okay, and if I subtract these two, like in this case it is mentioned with a capital R P Q, so it means Q minus P. It's a Q minus P. Okay, so if the 2 point is given to you in a free space, like consider 1 2 3, and second is the 2 minus 2 and 1. Okay, someone is asking find out the distance between these two. So how you can calculate? How you can calculate the distance? Distance between this 2 point. So suppose it is a R of PQ, then Q minus P. Q is 2 minus 1 and square it, plus minus 2 square it, 1 minus 3 and square it. This is basically gives me the distance between the 2 point. Okay, but we are not interested in a distance. What we are interested? Distance vector. Okay, so distance vector will be always mentioned with a capital R. So subtraction of this 2 point, like a 1 2 3 minus 2 and 1. So what you can write it down? 1 minus 2, it's how much? Just consider the x point for the P and Q. So 1 minus 2, it's a minus 1. So answer is minus 1 ax, 2 minus minus plus, so 2 plus 2, sorry 2, yeah 2 plus 2, so it's 0, 2 plus 2 it's 4, and 3 minus 1 it is 2, so it's a 2az. So you can mention it's a minus 1 ax plus 4 ay plus 2 az. This is called at the distance vector from the two different points. So hope so you may be getting this distance vector. I'm given one example, so definitely you may be getting the idea. So just see on your screen, there's a two different point P and Q. Have a P point is x of P, y of P and z of P, and second point is x of Q, y of Q and z of Q. If it is asked the distance, then you have to just make it the square. But suppose if it is asked the distance vector, then it is a subtraction of this 2 point, x of Q minus x of P, y of Q minus y of P, and same as z of Q minus z of P. Okay, and just make it the square under, just make it the square and find out the under root, then you are getting the distance vector. Okay, so this two vector is very important. One is the positional vector and second is the distance vector. By using the distance vector you can easily find out the distance. Okay, third one, it's called it the unit vector. So what is the meaning of this unit vector? So suppose someone is asking find out the unit vector. Okay, so if I know the vector A and if you find out the magnitude, how you can find out the magnitude? Any answer from your side?
Under root x square plus y square plus z square.
Yeah. Suppose vector A is equal to x, y and z, then what we are taking under root of x square plus y square plus z square. Okay. So unit vector is nothing but a vector divided by its magnitude. Okay, I'm just repeated. Unit vector, it's nothing but a vector divided by its magnitude. Suppose you are find out the unit vector in x direction. So instead of the small capital A of a, what you write down? It is A of x. If you find out the unit vector in a y direction, that is small a, and this is capital A, it's basically y. Okay, so already I taken the example, this one a of x, this is basically vector. Okay, and if I divide with this under root of ax square plus ay square plus az square, then it is the magnitude. Okay, so see how you can find out this magnitude, because capital A is mentioned with magnitude or maybe the amplitude part, and this is nothing but a vector. So this is vector divided by its magnitude, then it is considered as a unit vector. Okay, this unit vector is useful to mention the direction, to see the direction. Okay, suppose if it is x, so I can find out the unit vector is a of x. If it is y, then you are considered as a y, and if it is the z, then consider the unit vector it's along the z directions. Okay, so I can mention it, this is the ax, ay and az. I think we already discussed this part in this direction. So this is your ax, small a of x, small a of y, and this is a small a of z. Okay. All of you are getting some example on your screen.
Yes, sir.
Okay.
Yes, sir.
So see, I'm taking the two vector a of x. Normally x is always small. Okay, but in the right now is not mentioned over here. But consider this is a of x is small. 3az. These are the vector. Okay, so two vector is given to you. One is a and second is the b. Why you can consider this is the vector? Because see this b vector. Phi is your magnitude and a of x is basically a direction. That's why we are considering this is the vector. Okay, it's request to all the students try to find out the first components a plus b. All of you. I'm asking any random number and you have to give me the answer. It's very easy. You have to just add these two vector. Let's try to solve the first part a plus b, and this is the mode. So anyone of you are getting the answer? A
Yes,
plus
sir.
b is how
7.
much?
Sir,
A plus b is. First you tell me the vector form.
A
What is the answer of a plus b? Nobody knows.
6 2 minus 3.
See, if the points are in a vector representation,
Sir,
always
6
consider in a vector form.
plus 2ay minus 3az.
Okay, so how you can mention it? It's a 1 plus 5, so it is 6ax. Remember it. If it is the vector, you must have to represent in a vector. Otherwise, it may be wrong. Suppose you are mentioning the 6 and you are not mentioning the x, it may be wrong answer. Because a and b both are the vector right now. Okay, so first one is a plus b is equal to 6ax plus 2ay minus 3az. This is the answer of a plus b. Okay, and it is the mode, then just find out the under root of this a plus b.
Sir, it's 7.
It's 7. Just wait, I will be check if it is the 7.
Yes, it's 7.
Yeah, answer is 7. It's right. Try to find the second part. It's 5a minus b.
Sir, 10ax plus 2ay plus 9az.
What? It's a
10ax plus 2ay plus 9az.
something is wrong. First you multiply with a 5
Minus-
with a.
Sir, 2
minus
AY
2
plus 9
ay
is
Sir, mine.
21 is it?
First you multipy with a. So see, if you multiply with a 5 multiply by a, so it is
Sorry,
5ax.
sir, I did addition. Sorry, sir, my fault.
It's basically subtraction. So it's a 5 should be cancelled.
Sir.
So I think first x component is 0.
Sir, 2 AY plus 9 AZ.
Yeah,
No,
it's
sir.
right.
Minus 2 AY plus 21 is there.
Minus, yeah. Answer is minus 2 ay plus 21 az.
1 is there. Yes.
Okay. Any doubt in a and b part? See, these are the some basic examples, so I will be asked, and you may also
Sir,
getting some complex example.
सर वो फर्स्ट
Yes.
वाले पार्ट में 7 क्या था?
7 is basically magnitude. See, a plus b, but it's a mode of a plus b. So mode is basically magnitude.
ओके ओके अंडरस्टूड सर.
Okay. Try to find out the c.
So 2.
Okay. Any other answer? Endowment number 6. Endowment number 6. See, I know you are there, but you are not just replying to me. So definitely it's your fault. 19.
Yes, sir.
Can you tell me what is the answer for this one?
So 2.
It's a 2.
No,
Justified.
sir.
How you
0,
are getting?
0. Sir, 0.
Okay. Why it is 0?
So because there is no AY component in vector A.
Yeah. What they are asking, the components of A along the direction of AY, because AY is the direction. Okay. So see, vector A have a no Y components. So definitely answer is 0. Okay. Try to find out the third one. A unit vector parallel to 3a plus b. Okay. So first of all of you just try to find out the 3a plus b.
Sir, it's AX plus 2 AY plus 3.
So what is the answer of 3a plus b?
A 8ax plus 2ay plus 3az
Okay, 3 plus 2. It's 8. First one is a 8ax.
plus
Second
2ay
is
plus 3az.
yeah
2ay.
2ay.
And third one
And
3az.
okay, so this is the answer of the 3a plus b. Anybody knows how to find out the unit vector for the parallel to 3a plus b?
Sir, we will divide by its magnitude.
Divided by magnitude.
Yeah, answer is right. Whatever the answer you are getting for the 3a plus b, see this is a vector because it have a magnitude as well as the direction. Now just divide with its magnitude, so you are getting the unit vector which is parallel to, by default it is 3a plus b. Okay, so just find out the answer and tell me what you are getting.
Sir, a 8ax plus 2ay plus 3az divided by under root 77.
Yes, sir.
Under root of
77.
57. 77. Find out the answer, because in an exam you to also find out. Calculator is already given to you, so you can find out very well.
Sir,
Yes,
hello, sir.
yes, yes.
0.91 ax,
Yeah,
0.91 ax plus 0.22 ay plus 0.34 az.
yeah. Answer is the right. I'm just repeat the answer. Answer is 0.91 ax plus
Yes.
0.22 ay plus 0.34 az. This is the answer of the fourth parameter, a unit vector parallel to 3a plus b. Any doubt for this case?
No, sir.
Okay. Now,
No, sir.
given the second example, getting the example 1.2.
Yes, sir.
Okay, so mention this point. Point P and Q is given to you. P have a value is 0, 2 and 4, and Q have a value is -3, 1 and 4. We have to find out, the first is position vector P, distance vector from P to Q, distance between P and Q, and the vector parallel to PQ with magnitude of 10. (33)
Yes, sir.
Can you tell me the answer of first one? (33) I'm asking to you. (47) 47, are you there? (23) Anyone answer for the first one?
Sir, it's 2ay plus 4az.
Yeah. Who is this? May I know your name?
Sir, Het Patel.
Het Patel. Okay, Het. Answer is right. The position vector for the first part is 2ay plus 4az. Okay. See, the point P is already given to you. They are asking the position vector. It means you have to measure from the origin to the point P. So origin is 0, 0, 0. So directly you can mention it is the 2ay plus 4az. Try to find out the second one. Distance vector from P to Q.
Sir,
Yes.
it's minus 3ax minus ay minus az.
Minus 3ax minus 3
Ay
minus
minus
3ay or
az.
plus 3ay.
Sir, minus 3ay. No, sir, minus 3ax
Okay, minus 3ax
minus ay minus az.
minus ay. Okay, and minus az. Yeah, answer is right.
Sir,
So
plus
exactly
AZ.
the
Yeah,
what?
plus AZ.
See, whenever you are mentioning measuring the distance vector from P to Q, always subtract from Q minus P. Q is first and P is last. Okay. Only there is a generation of the in terms of the sign. Answer is almost similar, but sign is changed. Okay. Standard way you have to consider always from Q minus K. If you are moving from P to Q, it means Q is the larger one compared to P. So subtract Q minus P. Hope so you may be getting the idea.
Yes, sir.
Okay.
Sure.
So any doubt? All of you are I think getting distance vector.
Sir.
Yes, sir.
Okay. And if you find out the magnitude of this second point, B point, you may be answer of the third one. You may be getting the answer of the third one.
Sir,
Because it is the
3.317.
distance between the P and Q. So tell me the final distance between P and Q. How much?
3.317.
How much?
Yes, sir,
3.3.
3.3.
Okay, just wait. I will be check. Yeah, answer is right. It is a 3.1 something. Okay, try to find out the last one. A vector parallel to the PQ with a magnitude of 10. It's almost similar to this one. Yes.
Yes. So minus 0.3ax minus 0.13y minus 0.1az.
What about allow? You are talking about this one. Which one?
D option.
Say
For
first
the D.
a vector parallel to PQ. It means Q minus P. Whatever the answer you are getting, it's a PQ. Multiply with a 10.
Yes.
Okay. First Q minus P. Subtract the Q minus P. Multiply with a 10. This is the answer. So I think
So
final answer is, I think they are not
minus
paid.
30x.
Yeah. Okay.
Minus
But
30x.
in this case, they are not mentioning the unit vector. Basically, it's a unit vector. Something is missing over here. So if it is a unit vector, whatever the answer we're getting, take the magnitude and just divide it. It's almost similar to this one. Nothing is changed. In this case, they are asking about parallel to PQ. So find out Q minus P. It's already similar answer of this one. Okay. Multiply with a 10. So whatever the answer we are getting, just find out the under root of this one.
सर अगर वो यूनिट वेक्टर होता तो फिर उसकी मैग्नीट्यूड 10 नहीं होती ना?
Yeah, basically it's a unit vector. I think there is a missing the unit term over here because in answer they are find out unit one. See it. All of you are getting this minus 3 minus and minus 1.
Yes, sir.
Okay, and multiply the magnitude of the 10 and just divide with this magnitude part. So it's almost similar thing, but in this case the unit term is just not seen over here. So I think this is some printing mistake. Any doubt for this two example?
No, sir.
No, sir.
Okay, so on next lecture we are discussing about two components. One is the cross product and second is the dot product. Okay, so what we are doing, we are trying to find out the three different vector: unit vector, positional vector, and the distance vector. Okay, two rules: parallelogram rules and head to tail rules. And if you know the addition and subtraction, you can easily find out this kind of example, like a unit vector which may be parallel components along the y direction, something like this. Okay, so in the next lecture we are trying to multiply the two vector. Okay, suppose this is the two vector p and q, like 0 to 4 is the p and minus 3 1 and 5 it's the q. So if I multiply this two, what is the answer? Then it is nothing but a cross product as well as the dot product.
Sir, the head and
Yes.
tail means basically the triangle of vector addition, right?
What?
The second rule which you stated for the addition of vector, head and tail rule, is basically
Yeah.
the triangle of addition, right?
Yeah.
Okay, sir.
Okay. So any doubt for this vector algebra first part?
No, sir.
Okay.
No, sir.
Try to solve this example. I maybe within this week. I'm also uploading the your textbook on Team. Chapter 1 PPT is already uploaded. You can also see over here. So taking your attendance. Okay. Now we'll leave from this meeting.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.